Hi, Math 3 students. Today we are going to continue practicing solving rational equations. It's very similar to adding and subtracting rational expressions. Basically, you get your common denominator, and once you get your common denominator, you solve for x. So if we take a look here at number 61, what we want to do is we have to determine what our common denominator is going to be. What we could do here is factor this. We know that x squared minus x factors to x times x minus 1, okay? So what we can do is we can look and say, okay, well, this first guy, he's going to need an x, right? So we're going to multiply him by x over x, which gives us x squared all over our common denominator of x squared minus x. Now, in this one, I am going to distribute into the denominator. You don't always have to do that, but I'm going to just because I think it'll be nicer. Then we get 6. He needs the entire thing, right? So we're going to multiply him by x squared minus x. We distribute, and we get plus 6x squared minus 6x all over our common denominator of x squared minus x equals 1 over x squared minus x. All right, so at this point, everything has the common denominator. So this is where I like to figure out what values of x cannot equal. So we've got x times x minus 1. That's our denominator factored. We set the factors equal to 0, and we get that x cannot equal 0 and x cannot equal 1. All right, so if we solve this and we get one of those as solutions, we have to cross out that solution. So now what I'm going to go ahead and do is get rid of my denominator, and I get x squared minus 6x, x squared plus 6x squared minus 6x equals 1. And of course, we've got a quadratic here. So I'm going to combine my like terms. I get 7x squared minus 6x, and then I'm going to bring my 1 over so that it is set equal to 0. So at this point, what I want to do is factor. And unfortunately, this is one of those gross ones to factor. If you forgot how to factor using this method, you can use quadratic formula. But I am going to use factoring here, AC factoring. So you do 7 times negative 1 gives us negative 7. So I'm going to do negative 7 and positive 1 because that multiplies the negative 7, but it's going to add to give me my negative 6. So I'm going to do 7x squared minus 7x plus 1x, which is just x, minus 1. And then I'm going to go ahead and take out my GCF. So remember, you take out a GCF out of the first guy. You have to take a GCF out of the second guy. So the first guy, I can take a 7x out, and I get x minus 1. In the second guy, I actually can't take anything out, but I have to have kind of a placeholder there. You can take a 1 out. So I get x minus 1 there. So my factored answer here is going to be 7x plus 1, x minus 1. We set that equal to 0. So then when I set these, sorry, I know I'm kind of working in a funky order here. Once I have it factored, I'm going to set my factors equal to 0. And I get x is negative 1/7 for this guy. And here I get x is 1. So then I have to go check, and if you recall, we originally said that x cannot equal 1, so that means that this here is a bad solution, and negative 1/7 is our only correct answer. All right, let's try this next one. I'm kind of running out of space. There we go. All right, so let's take a look here. We don't have to factor anything here in the denominator. But what we do have to do is get a common denominator. So I'm going to say that my common denominator here is going to be x minus 2. So this fraction's good to go and this fraction's good to go. My first one is not. So I got to do 3x over 1 times x minus 2 over x minus 2. All right. So I end up with 3x squared minus 6x all over x minus 2. Plus 1 all over x minus 2 equals negative. And there's a couple different ways you could handle this negative here. What I'm going to do is I'm just going to distribute it to everything on top. So I get like a minus 2x all over x minus 2. So let's figure out what values of x, x cannot be. So if I set my denominator equal to 0, I get that x cannot equal 2. All right. So since I got my common denominator, I can drop that out, and I get I get 3x squared minus 6x plus 1 equals negative 2x. It's a quadratic, so we got to get it set equal to 0. So we're going to add 2x to both sides. And I get 3x squared minus 4x plus 1 equals 0. All right. And again, if you completely forgot how to factor using AC method, you can use quadratic formula. I'm perfectly fine with that. But I do think it's good for you guys to know how to factor using AC method. So that is the method I'm going to use. All right. So we take a look here, and we need to do 3 times 1. So we need to multiply to 3 and add to negative 4. So that's going to be negative 3 and negative 1. So I'm going to do 3x squared minus 3x minus x plus 1. And I take out my GCF here. I'm going to take a 3x out, and I get x minus 1. And then this is one of the ones where if we look, in order to get a guy that matches here, we got to take a negative out. So I'm going to take a negative 1 out, and I get x minus 1. All right. So then my factored form here, remember I take this guy, and then I take this guy. So I've got 3x minus 1, and then x minus 1. And I can go ahead and solve this by setting these equal to 0. So I get 3x minus 1 equals 0, x minus 1 equals 0. I get x equals 1/3, and x equals 1. Then I have to go ahead and check. At the beginning here, we said that x cannot equal 2. Neither of these are 2, which means that they're both good to go. So I've got 2 solutions here, 1/3 and 1. All right, let's try another one. So taking a look here at number 63, my common denominator that I'm going to try and get here is going to be x. So this first guy, my 1, I'm going to do 1 over 1 times x over x, and I just get x over x. And obviously this guy here is good to go. He's already got the common denominator. And then my negative 6x, I'm going to multiply by x over x to get my common denominator. It's going to be negative x squared all over x. So I got my common denominator. I'm going to set my denominator equal to 0. And basically x cannot equal 0. So then we go ahead, we get x minus 1 equals negative 6x squared. It's again a quadratic, so we're going to add 6x squared to both sides. And we get 6x squared plus x minus 1 equals 0. We've got another quadratic here. So we multiply, we've got negative 6. So what multiplies to negative 6 and adds to 1? That is going to be 3 and negative 2. So I'm going to do 6x squared plus 3x minus 2x minus 1. I'm going to take a GCF out of my first 2 here, and I get 3x, which gives me 2x plus 1. And then here I'm going to have to take a negative out again. So it's just going to be negative 1, and I get 2x plus 1. So then when I write my factored form of this, I get 3x minus 1 times 2x plus 1. Then I just set them equal to 0. So I get 3x minus 1 equals 0, which gives me 1/3. And I get 2x plus 1 equals 0, which gives me negative 1/2. And of course, I got to go check what x cannot be. We said x cannot equal 0, which that's not what we got. So we are good to go. And we've got 2 solutions for this guy. All right, next one. So let's go ahead and get our common denominator here. Looking at this, it looks like my common denominator is going to be x times x plus 1. So this first guy here, I'm going to have to multiply him by x over x. And I get x squared all over my common denominator that I wanted. And then this next guy, I've got 4 over x, and I'm going to multiply him by x plus 1 over x plus 1. I distribute, and I get 4x plus 4 all over x times x plus 1. And then we've got equals, and we've got, and again, I'm just going to distribute this to the top to make my life easier here. And I've got x plus 1, so he needs to be multiplied by x over x. So we get negative 2x squared all over x times x plus 1. All right. So at this point, what I want to do is go ahead and figure out what x cannot be, right? Because I've got my common denominator here across the board. So I would say that x, we can say, we've got our common denominator of x times x plus 1. We'll say x equals 0, so x cannot equal 0. X plus 1 equals 0, so x cannot equal negative 1. So I'm going to go ahead and I can drop out my denominator here. So I've got x squared, and do not forget to distribute the negative. And we get minus 4x minus 4, you got to distribute it to everything behind it, equals negative 2x squared. Again, we've got a quadratic. If you notice, there's a lot of quadratics today. So we're going to go ahead and get it set equal to 0. So we get 3x squared minus 4x minus 4 equals 0. So again, we're going to go ahead. I get a negative 12. What multiplies the negative 12 adds the negative 4. I'm going to do negative 6 and 2. And unfortunately, I'm running out of space. So let's see. What could I do here? I'll just fix it by making it smaller. All right, there we go. All right, so then I'm going to rewrite the negative 4. I get 3x squared minus 6x plus 2x minus 4. Got to look here and got to look here. What can I take out of my first two? I can take a 3x out, and I get x minus 2. Then in my second group, I can take a 2 out, and I get, again, x minus 2. I know I did a good job because I got that same guy twice. So factored, I'm going to have 3x plus 2, x minus 2, and then we set those equal to 0. So 3x plus 2 equals 0 gives me x is negative 2/3, and x minus 2 equals 0 gives me x is positive 2. And of course, we want to go make sure that those are good solutions. In the beginning, we said it cannot be 0 and it cannot be negative 1. Neither of those have to be excluded, so we are good to go. All right, number 65. So if I factor this guy here, I get x times x plus 1. So you can tell here that my common denominator is going to be x times x plus 1. Now my first guy is missing both of those. So I'm going to do 2 over 1 times x squared plus x squared plus x. Now the reason I'm distributing this is because it's kind of easier to multiply 2 by x squared plus x instead of x times x plus 1. It just makes the math a little bit nicer instead of having to distribute twice. So we do this and we get 2 x squared plus 2x all over x squared plus x. And then my second guy is good to go. So I just do minus 1 over x squared plus x. And then this guy is in fact missing the x, right? He's got the x plus 1, but not the x. So I'm going to put my negative on top. So I've got negative x over x plus 1. Multiply him by x over x. I get negative x squared all over my common denominator of x squared plus x. So then we have to figure out what values x cannot be. So we say x times x plus 1 equals 0. So x equals 0, x plus 1 equals 0. So x cannot be 0, x cannot be negative 1. All right. So then what we can go ahead and do, since we now have our excluded values, is we could drop out our denominator and actually solve the equation. So we end up with 2x squared plus 2x minus 1 equals negative x squared. Again, we got a quadratic, so we got to bring this over. We get 3x squared plus 2x minus 1 equals 0. I'm going to go ahead and multiply. I get negative 3. So what multiplies negative 3 adds to 2. That's going to be 3 and negative 1. So I'm going to do 3x squared plus 3x minus x minus 1. I take a 3x out. I get x plus 1. I got to take a negative out, x plus 1. So I get 3x plus 1 times x plus 1. So when I set those equal to 0, I get negative 1/3. And I get negative 1. Now, if we look back, negative 1 was actually one of my excluded values. So I only have one solution here, which is, ooh, did I mess up? I did mess up. Oh, no. I wonder if you guys caught my error. This should have been a minus because I took a negative 1 out. So then in this case, minus. This is a minus, which makes this positive. So the correct answer is actually positive 1/3. All right, hopefully y'all are hanging in there. We are almost there. So let's go ahead and try number 66. So the only guy we really have to factor here is this denominator. It becomes x plus 3. So that's going to be our common denominator of x times x plus 3. So first guy, he needs an x. So we get x squared plus 3x. And then my second guy needs everything. So I'm going to do x squared plus 3x all over x squared plus 3x. Again, I am distributing the denominator because I feel like it makes things easier in this case. You do not have to do that, but that's just what I like to do. 5x squared plus 15x. And this last term is good to go. All right. So at this point, what I would recommend doing is finding our excluded values. So if we set our denominator equal to 0, x times x plus 3, x cannot equal 0, and x cannot equal negative 3. All right. So we've got our excluded values. We can drop out our denominator. We get x squared plus 5x plus 5x squared plus 15x equals 9. We get 6x squared plus 15x, and then I'm going to bring my 9 over. I get minus 9. So actually, I have to hold on. Yeah, I have to factor a 3 out here. So we get 3x, no, we get 2x squared plus 5x minus 3. Still, we got to do AC factoring. So negative 6, add to 5. That is going to be a 6 and a negative 1. So we get 2x squared plus 6x minus x minus 3. I am going to take a 2x out here, and I get x plus 3. I can take a negative 1 out, and I get x plus 3. So when I factor this, I get 2x minus 1, x plus 3. So we can go ahead and set our factors equal to 0. Now, you cannot make 3 equal to 0, that GCF that we pulled out. So setting 3 equal to 0 is like impossible. You can't make 3 equal to 0, but you can set these guys equal to 0. So we're going to do 2x minus 1, which gives us 1/2, and x plus 3, which gives us negative 3. However, if we look back, we originally had said that x cannot be negative 3 based on the denominator, so we cross that bad boy out, and our only answer is 1/2.